So homework corrections are due the day of the final. I want you keeping up with new homework, doing old corrections whenever you can. I make the tests and quizzes due so I have enough time to grade them. My God, if I made them due the day of the final, holy shit. All right. Plus, they are the biggest chunks of your grade. So I want your grade to be sort of as up to date as possible throughout the semester. Starting test 2, after test 2, I'm going to give you guys, maybe even after this probability quiz that we have coming up that's on your homework sheet, I'll give you a grade sheet summary. If you want to know before that what your real overall grade is, come see me. My office is way there, right down at the end of this little hallway of buildings, right? So far. Okay. Come in there, we could do some scenarios. I did that this morning with somebody. Said if you make the corrections and do all this, you'll need this much to average on everything left to pass the class. So I can do that shit because I'm a math dude. Math dudes with spreadsheets, watch out. We can do all kinds of shit. Okay. So we're about to get into the probability section. Do you guys remember the first day we did that birthday thing?
Yes.
You guys remember that? Some of you guys knew about it coming in. Some of you guys, hopefully some of you guys were like, whoa, holy shit. What did we end up, like 3 pairs, 2 pairs? All right, something insane. Just the other day, I was in a group of like 6 people, and somebody else had my birthday. I'm like, okay, that's freaky as shit. But it happens. Probability is not hardwired in our brains. It isn't. Which is why it is so counterintuitive very often. Right? But probability is so fundamental to everything. I have family on the East Coast, so Florence was coming. They live in Virginia Beach. Florence was coming, so I'm watching all the probabilities of where it's going to track is all probabilities, right? The further it gets from the hurricane, they're like, we just don't have a flipping clue out here, shit. But it is a track of probabilities. It's neat, right? So there's a use for probabilities. How probable is it we should evacuate or at least tape our windows? Right? Of course, if you lived in San Diego your whole life, you have no idea what this shit a hurricane looks like. You know, in the wild, outside. So going into this, you have to really kind of follow where the formulas come from. They are a little, some ideas probably are a little counterintuitive, but the formulas actually make a lot of sense. Thank God. Let's see if that's true. Let me just see if you guys understand the basics of probability. How many left-handed people are there? You guys willing to show yourselves? I'm not left-handed. So 2, 3. Be proud with the shit. Right, you guys are like, I'm not going to throw you. Get out of here. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 6, 28, 30, 32, 34, 35, 36. So there's 36 people. And 3 are left-handed. If somebody came in here and picked one of us at random, what's the probability they picked a left-handed person?
3, 1, 12.
Yeah. They have 3 chances to pick a left-handed person out of 36 total things that could happen. I like it. Now, let me just point out, isn't that the same as what percentage of the people in here are left-handed?
Yes.
Of course, the percentage of things that are something is equal to the probability of picking that thing at random. Mm-hmm. So like you said, this will be 1 out of 12, which is whatever the hell it is. Is that 8.3%? I think so. Haha. All right. Certain things just happen enough that as a math geek, you start to remember certain numbers. How are we doing so far? You guys decent with that? What would you tell the person? Can you see this mistake? Somebody would look at this problem, and the mistake would be, they would say the probability is 1 out of 3. What mistake? Can you see the mistake they made? Can you understand what they were thinking? How many left-handers were there? And they want to pick a left-hander, so they were looking at it as they have 1 left-handed person out of the 3 that are there. But you see how that's so desperately wrong. You don't have one chance out of 3 total things. If I pick somebody at random, there's 36 total things that could happen. And how many chances out of that to have a left-hander? 3 out of that. Are y'all cool with that? That is the most common mistake I see, is that. So what is the fundamental idea of probability? Number of things that match what I'm looking for. Divided by the total number of things that could happen. All right, that is the fundamental idea of probability. That never changes. Now the formulas we use to get it will get more complicated, and the things we do will get a little more complicated, but they all relate to this idea. They all have to, because this is what probability is. Period. Okay. Today, by the way, today is going to be a lot of just exploring the shit out of probability. We might get a few formulas figured out. The next class is going to be, there's going to be a handout. We're going to really make sure we have all the formulas, and then you guys are just going to do the handout practice. I'll also have a practice quiz. If you look at your homework sheet, there's a date for a double quiz. Why is it called a double quiz? Because it's twice as long and counts twice as much as a normal quiz. Right? Say again? September 26th. So I'm going to have a practice. This is the one quiz I have a practice quiz for, with an answer key, just like a test. I used to call it a mini test, and the people freaked out. Huh? I did that? See?
Yeah. Then you have to schedule something, and you have to schedule.
Exactly. Yeah, so I don't want people freaking out and misunderstanding and turning stuff in. It's due the day of the test. It's not really a test. So it's a double quiz. I'm going to set up a problem that I always give a problem like this. There will be other problems, but there's definitely going to be a problem like this on the quiz and on the final. It's something called a contingency table. Oh shit. So contingency is a word related to, well, we're going to do this if this. So here's an example. Say again? We're not there yet. Yeah, it's going to build up to that. Yeah. Were you doing sign language to me? I like that. You know, like something's going to get through to this guy. So say I ask a bunch of men and women a certain question. Right? It's too early to be creative. I'm going to let you guys decide what the question was. All right. So I asked them some question, like, should Kavanaugh's confirmation be delayed until they find out what the hell's going on? Right. I love the language, just echoing language. We'd heard before from somebody prominent. I don't know where you are and things, but just keep it yourselves. And do you guys know, if I say the word Kavanaugh, who the hell's that? Everybody know who Kavanaugh is? He's supposed to be the next Supreme Court justice. If you're paying any attention, there's a lot of shit to be interested in. Let me just say it that way. Right? Somebody who's on here. All right. So men, women. So I asked them the question. It could have been the one I just said, right? Okay. You know what you did. So here's the answers I get. Help me out. Can somebody tell me, what does this 38 mean? Women who said no to this question, whatever it was. So how many people said yes? 14. 14 people said yes. I just want to make sure you guys can read. For some reason, this table gets misread so much. Nothing amazing about this table. It's very simple to read. So how many people said no? Maybe so. 7. How many men were there that I talked to? 41. I like it. How many women were there?
43.
43. How many total people were there?
84.
What do you think this person here did that wrote this? What did that person? Don't write that. Do not write 168 because that's insane. They added these people to these people. Well, these people are these people. So you count everybody twice. Don't do that shit. There's 84. And then if you check, this way better be 84 also, right? Is it? So yes, 84.
So you add the lines up and put it at the end.
Yeah, what does this 41 mean?
The 41.
That's how many men there were.
Okay.
And again, why does it make sense? I'm taking a minute to do all the totals because I'm going to ask you probability questions. And probability questions are always over the total. I like it.
So is that column always going to be for totals?
See again?
Is that
Yes.
column-
So this
that-
is totals, this is totals.
When we make it, do we label it or?
Up to you. I don't care. What I'm going to do is I'm going to give you a table that has empty spots on the outside in an attempt to remind you to do that. If you want to label it, feel free. I like it.
So then,
So pretty cool with me so far.
Yeah.
You guys have seen this kind of table in some form before, yes?
You always go down no matter what. Like it's always adding down and I don't know.
Yeah.
Because you want to confirm that you did it, right?
Yeah, if 11 men said yes and 3 women said yes, then 14
And
people
so
said
then-
yes.
that total is the total of yes, no's, maybe so.
Yes, 7 people said maybe so. 43 people were
Women.
women.
And then the corner is equal up to both.
The total people. Nothing too amazing. If there were 41 men and 43 women, there must have been 84 people. If you add these people in, I'm curious what gender you think they are. Right? And again, I don't want to get into gender politics. You identify as something, it's fine. Just be careful about where we go. Okay. So now I can ask you all kinds of probability questions. I can ask you some very, very, very basic ones. Like, if I pick one person at random, what's the probability that person is the man?
So it's 41
One over 84.
Yeah, there's 84 people. And out of those 84 people, there are 41 chances to pick a dude. So it is just the chances you get what you're looking for out of the total things that can happen. That's the basic idea of probability. It's probably I picked somebody that said maybe.
7 over.
7 over here. Somebody help me out. Did anybody do what's 41 divided by 84? It's 0.496. I'm making this shit up.
0.48809.
48801?
Yes.
Okay. We're going to take probabilities out to 4 decimal places. Just because we're all crazy. At least 4. If you get a probability that's 0.00003, don't make that 0. Because then you're saying it ain't going to happen. And this is saying, yeah, it could happen. But so take it to 4 places normally, unless it's really tiny. Then take it out further. How are we doing so far? Oh shit. Hey, remind me, how many places are standard deviation supposed to go? At least 3. And so you can make it 4. Basically in this class, if you make everything 4 places, unless I say otherwise, you should be fine. There's a shortcut way to remember all this shit. Okay, What about 7 out of 84? What's that? So this would be 48.81%. Hopefully everybody knows how to go from decimal to percent.
It's 0.83.
0.08?
0.083 continuous.
Really? Oh, yeah, it is.
Yeah.
There you go, because it's 1 over 12, which we talked about earlier. So that's 8.3%. Okay. A little line, of course, means it
It goes up.
keeps going like that forever. What's happening? Oh, this guy? Okay. I was wondering if everybody would just pick it up. How do I read this statement? What does this say? Probability of a man. The probability. So I pick one person. So this is the probability that I pick a man. So sometimes I'll say it in English like that, and sometimes I'll say it in Naffish, which is what this is. I like it. Okay, so let's go a little bit deeper here. What's the probability that I pick somebody who's a woman, or they said no?
43 over 84 times.
So what's always the top of a probability? The total number that
You're looking for.
matches what I'm looking for.
So
I call or the nice bouncer.
so it's 50.
Go with me for a second. You're on the right track. What's a bouncer? Who's a bouncer? What do they do?
They stand at the door and they decide.
They
whether
keep
to get
people
in.
out.
Yeah.
Right? Or they let a few people in. So or is the nice bouncer, because if I go to a club and they say, all right, I'll let you in if you dress nice, oh shit, or you make a lot of money, teacher, or you know Joe, I know Joe, hey Joe, and I go in. That's the nice part. You just got to meet one of those conditions and you can go in. So or increases the probability that I'm going to get in. Does that make sense? You can do this, or this, or this. I'm getting a higher probability. And is going to make the probability smaller, because that's the mean bouncer. And is the mean bouncer. You got to know Joe the part-time. I know Joe, and you got to dress nice. And you got to make, I was already helped you. So, for example, has anybody ever looked for scholarships? Anybody ever looked for scholarships? If you haven't, you're kind of crazy. If you ever read through the requirements for getting a scholarship, I love this. So before the days of the internet, there were these days. Back in the olden times, there was this giant flipping book that you go and it would be updated every couple weeks or something crazy. Giant book and you open it up, scholarships, and you start reading. You must be a math major. Check. And you must have this GPA. Check. And blah, blah, and blah, blah, and you must be a woman. Why don't you put that first? I mean, that's an actual true story, to be honest. I was like, yeah, oh, boop. So that's restricting, making things small. Or should make the answer bigger. And should make the answer smaller. I love it. Now, does that tell you exactly how to do the problem? No. But it gives you an idea of why what we do makes sense. So probably a woman myself, there's only 43 chances to get a woman, but I'm also going to take in everybody who said no. But what's wrong with saying 43 plus 63?
You're adding women twice.
Well, one thing that's really, really, really wrong. So this does not equal. Come here. Are you looking over there? Whee! Yes, you are. This does not equal 43 plus 63 out of 84. Because that would be 106 out of 84, which is bigger than 1. Holy shit, what's the largest any probability can be? 1. 100%. Do not get this answer and circle it and keep going. If you don't see why you're getting this, at least say, I know it shouldn't be this. Right? Because if you just leave it, I'm going to take more points of them. Like, do you understand probability can't be, the 110, give 110%. That's mental. That's not probability. Right? There's a 110% chance of rain. Are they bigger raindrops? What's going on? Is time going to back up and we get rained on a second time? This shit is 110% of something happening. No.
So no more than that.
Totally. Think about what would it mean for a probability to be higher than 100%? Doesn't make 100% means it is going to happen. What would 110% mean? It already happened before you even, it's like you got up before you got up. What the shit?
Psychic.
Yes. All right. Maybe. So realize that's the problem. All right. So that at least should tell you that or doesn't just mean add. But it should be based on addition, right? Well, if I count these 43 people, have I counted anybody who said no already?
Yes.
Yeah, 38.
Yeah. 38 of those people said no. So if I do 43 plus 63, how many did I count twice? 43 plus 63. I counted those 38 twice. So I should do what? Subtract them off. Now, some of you guys hopefully are like, why would you do all that shit? Couldn't you just do 43 plus the people you didn't count yet? Yeah, of course you get the same answer, right? It's 43 plus 63 minus 38. Why is the bottom still 84?
Because it's a total.
Yeah, because I didn't tell you it was anybody specific. It could be anybody. So the only time the bottom changes is if I actually give you more information. We're going to see that in a minute. But the top, is everybody with me? 43 women plus 63 people said no, but you counted 38 of them twice. But what is 63 minus 38?
68. Oh, sorry.
25. And see, that's 25 right there. 68 out of 84. Sure the hell it is.
0.8095.
Say again.
0.8095.
Did you learn? Let me stop there for a second. Say again.
One more time, please.
Do what?
Explain.
Okay. So if I count all these women, so that's 43 people, right? And I count all the no's, that's 63 people. Do you see how I counted those people twice?
Yeah.
So if I said, let me count all the women in here. Right? Now let me count everybody who's wearing a hat, right? Wouldn't I have counted you twice?
Mm-hmm.
Yes, and I would have counted Katie twice. I would have counted you once. Right? There's one dude with a hat. You guys with me?
Yeah.
That would not have been true. That would have been me lying, double counting people. Right? That's how you get large crowds at inaugurations. I don't know. So we have actually, let me just point this out. We have a formula staring us in the face. We have a formula for OR. What is 43 out of 84? No. What does it represent?
Women out
The
of
probability of a woman, right?
Yeah.
What's 63 out of 84?
Probably
somebody said no. What's 38 out of 84?
Both of them.
They're a woman and they said no. Oh, that's it. So that would be the formula for that OR statement. Why do I have to subtract something off? Because if I just blindly add two groups together, I might have counted some of them twice. Because things could belong to both groups. Now, did they even need to use that formula? No, you could have done this. You could have just been smart and said, I count those 43 women, and there's 25 men who said, no, I haven't counted yet. Let me just add those together, Jeff. So we're going to talk about formulas. But the funny thing is, you don't hear math people say this very often, the formulas get in the way very often. If I can count what's going on, I do it that way. I don't try to force it in the formula unless I want to. It's just easier just to count. Right? Probability is all about counting stuff.
And with a different table, you'll just replace the men and the women?
Yeah, yeah. If I made, what do you mean? If I made a different table, this could be
Yeah, so
people under 18, people over 18.
So,
The idea of the table is not going to change. These things will change what they are, but. So what's the formula then for probability of A or B?
A
Add up all the A's
plus B,
and all the B's minus
P,
all the
A
things
and
that are
B.
in A and B. That is the formula for OR. So OR means basically add,
so A.
but it does have that little adjustment.
So A would be on what side of the table normally, and B would be the opposite. I'm confused.
Yeah, it would be kind of silly for me to say what's probably pick a man or a woman. That's going to be 100%, right?
Yeah, but so A would be
It doesn't matter where they
It's gonna
are.
confuse me.
No. Don't try to memorize locations on tables. If I ask you an OR question, what you can do if you want to always is you can add one group to the other group and subtract off anybody that's both. So let me ask you this. What if I ask you, what's the probability I pick somebody who said yes or they said no? So how many said yes?
14,
Plus how many said no?
16.
Minus how much? How many said yes and no? Did anybody say yes and no?
Maybe so.
That's maybe. That's a different answer, right? Did anybody say yes and no? No. So why is there nothing to subtract? Because these are separate. These are told they have nothing in common with each other. So the formula doesn't change worth shit. It's still subtract all that's both. Well, there's zero that's both. This situation we're talking about right now, where they don't share anything, that's officially called mutually exclusive. Let me finish this out. Mutually exclusive. When I say exclusive, what do you think?
They're only seeing each other.
Uh-huh.
They're only with each other, that's,
Mm.
no?
Exclusive. Some places exclusive. This is like the mean bouncer place. It's an exclusive place. When somebody tells me that, I'm like, oh, so they're not going to let me in. Is that what you're saying? Exclusive. The word there is exclude. They exclude certain people. So Mensa. Anybody ever heard of Mensa? Mensa is exclusive because they only let you in if you have a certain IQ. They're exclusive. They exclude people. Mutually. What the shit does that mean? What does mutually mean? If you do something mutually with somebody, that means you're doing it together, right? So they mutually exclude each other. The yeses say you can't be in here, and the no's say you can't be with me. Nah. They mutually exclude each other, which means they have nobody that's in both. Does women and no, are they mutually exclusive? They have stuff that's in both. They don't mutually exclude each other. Like, you can be both, that's cool. Yes and no, that, no. You must be yes or you must be no, right? All right, okay. Maybe.
So mutually exclusive means you cannot be yes or no.
Oh, it can't be yes
And no.
and no. So the word and in English sucks because it could mean a lot of things. If I said you and you come with me, you're both going to come with me. Right? But and could also mean, well, you can't get in here unless you know Joe and you make money and, right? That's the mathematical meaning of and. You must do all these things. Or means you have to do at least one of them. That's why it's more inclusive. Just come on in. I'm sorry. Yeah. Did somebody have a question? No. Okay. So let me ask you this. It's probably that I pick a man given they said yes. This is new. This is different. What does that mean? What is it that I know? They what? I know they...
A man.
No.
And
Let's read this again. The probability they're a man, so I don't know if they're a man. Given they said yes.
So the people both.
No. So what do we know?
So 11 and
We know that they
had to say yes.
said yes.
They said yes, thank God. Okay.
And they're a man.
Given that they said yes, what's the probability they're a dude?
62.
Wait.
Oh, you gotta read that backwards.
No, you don't. The
11.
probability it's a man. So do I know it's a man? No, the question is, what's the probability it's a man?
Yeah.
Could be a woman, I don't know. Given that they said yes. Oh, so I know they said yes. I gave you more information about it. So what's going to change now?
You gotta look at the yes and
Yeah, the bottom is not going to be 84 anymore. Who can I throw out?
All the no's and maybe
Yeah, all the people that didn't say yes. So what's my whole universe now? Is the yes.
11 and
I can really just cover up all this other shit. So out of 14 people, how many said, well, how many were a man?
11.
11. So I really want, this is what I was saying earlier, and when I said it, you were like, whatever the shit, just show me. But I said, the basic idea of probability never changes. It's the way we get there could get more complicated. The bottom is always the total number it could be. I know they said yes, so it could be 14 people. We use givens all the damn time. Given that it's 3:30, should I leave to go home? No, I'm going to stay for a while, let the traffic flipping die down so I don't go insane. I'm one of those people that my friends would give me little toys to play with because on the, because on the road, oh, I hate traffic all the time. So I live in the greatest place for that. We use givens all the time. That given is actually one of the things that's hardwired into us. Given that I saw a saber-toothed tiger that way, I'm going to go that way because there's a higher chance I'm going to live if I go that way. All right, so this is actually related to survival. Stop for a second. Let's do another given. Oh, by the way, what's the probability I just pick a dude, period, without any more information? We did that first, didn't we? That was 41 out of 84. Help me out. What's 11 out of 14? What's that?
0.7857.
7857. What's 41 out of 84? I can't remember.
48.
Oh, yeah.
What's that?
48. 0.481. Wait, sorry. 0.4881.
Oh, okay.
Yeah, you're right.
So the probability I pick a dude was under 50%. It was 48.8%, right? If somebody tells me the person said yes, does the probability it's a dude change?
Yeah.
We try it again. So probability dude was 48.8%. They tell me one thing about this person. They said yes. Does the probability it's a dude change?
Yeah.
It changes. It went up. So this is what's called a conditional probability. The probability is a man. It might change on the condition that they said yes, then no, whatever. It's a conditional. In the condition that they said yes, what's the probability to do now? Did it change? It did change. So it's very much like, I always give this example. I don't know why. I see somebody way off in the distance. I can't tell if it's a man or woman yet. They're too far away, right? All right, somebody's coming. What's the probability it's a man? 50%, roughly. In actuality, it's a little higher than 50 because more men die off, and nature said, let me make more men because you guys die off early. Well, let's just say it's 50. I don't know if you guys knew that. So often I have but then I realized that they just got off a Harley-Davidson motorcycle. And I love it when I have women that are like, what the shit? Women ride. No. Is the probability it's a dude? Is the probability it's a dude staying the same? No, the probability it's a dude just went up. Did I just say that no women ride Harley Davidsons? No, I did not. I said the probability it's a woman went down, probably it's a dude went up. Because who rides Harley Davidson more often? Dudes! I'm not saying shit about whatever. I'm just saying the probabilities don't give a shit about politics or whatever issues. They just are, here's what's going on. That's changing the probability. Some condition changes the probability of something else. Okay? That's another reason why it's called conditional probability. Now these two events then, would you say that the event man and the event yes, the event man and the event yes, would you say that they are independent of each other? What does independent mean? If I'm independent from my mom, she can't decide for me, can't affect me. So would you say that the event man and the event yes, are they independent? Does one not affect the other one? No, good. What happened? Did me saying that the person said yes, did it affect the probability as man? Did it? Please. What's the probability as a man in the first place? 48%. If I tell you they said yes, did I change the probability it's a man now? Yes, I totally did. Can you see that number is different than that one? I love you guys. All right, so here's the thing. Let me put it over here.
You can see it.
Okay, I'll get it. So the test for independence. If I ask you, and by the way, just to remind you guys, we're doing a lot today, right? Because it's all connected. That's why I like to go through a lot of ideas, because they all connect to each other. Give yourself a break if you're not quite 100% yet. You shouldn't be, right? So if I ask you, are A and B independent? Independent. There you go, John. It's like banana. Are A and B independent? You cannot answer this question by talking about, well, you could be a woman and do this. No. This is a completely mathematical idea.
So
I'm going to show you what to do.
A and B are.
If I ask you, are, just like I asked you earlier, are being a man and saying yes, are they independent? No, they are dependent. These are dependent. Why? Why are they dependent on each other?
Because they change each other.
Because one happening affects the other one's chances. I did not say that one won't happen unless the other one does. People hear that somehow. That's not what dependent means. It means that one is affected by the other one. That's all it means. You don't say, well, you could be a man and say no. So no, that has nothing to do with the question. Do you guys understand what I'm saying? So you have to. So if I ask you this question, what you do is you check the probability of A versus the probability of A given B. To be independent, what must be true? If they were independent, one doesn't affect the other one, what would be true about these? They would equal each other. Because they are both questions about the probability of A. They are both questions about the probability of A. So if that really is independent from this, it should not affect this. So the only way to be independent is if probability of A equals. Get out of there, not equal to. Equals probability of A given B.
A and B are opposite, or
They are just two things. They are two anything.
which side of the table are they on?
I don't know why you're so curious about what side of the table. That doesn't affect anything. The side of the table they're on does not affect anything we're talking about. Nothing. It does nothing. So don't memorize sides of tables, right? Do you understand what I'm saying? The side of the table has nothing to do with what we're discussing.
Well, then how do you know how A and B are related to each other?
I don't. I have to look at it. Look at Ash. This is not any specific situation, is it? It's an idea. I can apply it in any situation. So if I said, are woman and saying maybe independent? Just a second over there. Are woman, are the events woman and saying maybe independent? Are they independent? What do you check? What do you check? You look at the probability of woman, and you compare that to the probability of woman given maybe so.
So where do we have to look for the woman?
Here we go. What's the probability of a woman? What's probably pick a woman? 43 out of 84. Which is what? 0.5, 0.512? I don't know.
0.5119.
So 0.512, 5119? Don't give me too much credit. I can get close. Probably a woman, given that they said maybe so. So how many people am I talking about now in this problem here? How many people am I talking about? Given that they said maybe so. 7. So out of 7, how many match what I'm looking for?
2 or 7.
2. What's 2 divided by 7? 28.2857?
5 cents.
All right, don't be excited about that. The over 7 thing happens a lot, so you sort of start to remember. So our woman and the event maybe so are those independent. Why not? Because one happening changed the probability of the other one happening. Specifically, the probability went down. So the person said maybe so, that seems to cause their the probability that they're a woman to go down.
I have 2 questions. One, can you define happening? Like, what is happening when you say happening?
So with this kind of question, when I say what's probably as a man, I say that probably a man happens. Sometimes I might say that. So what I mean by that is, what am I doing? I'm picking a person. So what could happen? It could be a man, it could be a woman, right? So probably man means the man happens. I could say that sounds kind of, man happens. It's like, what the shit? But that means that's the result of what I just picked, is it's a man. So happens, I'm not sure how I used it over here. So over here, what do I know happened? What do I know happened? I picked a person that said maybe so. I know that happened. I don't know what gender they were or what sex they were, but the probability that they're a woman just went down. Yes?
So if those two answers were the same, then it would have
If those were the same, they would be independent. That makes so much sense. If maybe so happening doesn't change the probability it's a woman, they don't give a shit about each other. They don't care about each other. You happen, that's nice for you. Right? So we will look at a situation where that's true in just a minute. Okay, maybe. Yes?
In this table, are there any independent variables?
Well, we'd have to look at, in order for me to construct a table, it would almost be impossible for me to construct one by accident that just happens to have some independent stuff. It's really difficult to be truly independent because things affect each other. In fact, you can get all the way into the little butterfly flapping its wings on a monsoon, right? It's not just Ashton Kutcher movie. It's a whole idea that's been around forever, the butterfly effect. We won't go all the way there. Holy shit. But let me do this. Let me give you an example of a situation where there are definitely independent events. Okay, yes?
As long as like they're the same numbers, and that means it's independent.
Yes. Yes, if these two things, if this, whatever the shit A is, what was A in this case? Woman. What was B? Maybe so. Right? Does anything affect what I check? No, this is period what I check. Doesn't matter where they are, what they mean, whatever. This is what I check. Period. I like it. I like it. So let me give you a situation where it is independent. What time we got? Oh, wow. You're all like, oh, shit. We got so much time. It's awesome. Maybe make a situation. I'm almost certain there are people out there right now that aren't too familiar with cards. Anybody not familiar with cards? Like how many suits are in a deck of cards? There's hearts, diamonds, spades, and clubs. I like it, right? All right, so let me write this up here. So to answer your question a little better, I could construct a table where there would be independent. I'd have to be really careful to make sure the proportions come out the same. That's the idea. And if I just make shit up out of nowhere, more than likely I ain't going to get something that's independent. So in a deck of cards, is he still going? He's a trooper, man.
It looks like he's still going.
Yeah, he's still going. Let me start on. He's about to give up.